Welcome to the DIY Honda Garage channel. Welcome to this presentation on diagnosing DTC P0712, which stands for short in ATF temperature sensor circuit, specifically for the Honda Civic models manufactured between 2006 and 2011. This error code suggests there is an issue within the electrical circuit linked to the automatic transmission fluid, ATF temperature sensor. The ATF temperature sensor is a critical component located within the transmission, responsible for monitoring the transmission fluid temperature. It sends this vital information to the powertrain control module, PCM, which in turn adjusts various engine and transmission functions to optimize performance and fuel efficiency. The error code indicates a short circuit problem, which is primarily an electrical issue rather than mechanical damage within the transmission itself. Before diving into troubleshooting, it's essential to record any freeze frame data and onboard snapshots using Honda Diagnostics System HDS tools, as this can provide valuable context for diagnosing the issue. With that introduction, let's explore the detailed error description. DTC P0712 indicates an electrical problem specifically within the ATF temperature sensor circuit, indicating that the sensor is not operating as intended. The ATF temperature sensor, typically located within the transmission housing, plays an important role in ensuring that the transmission fluid's temperature is within acceptable limits. If the transmission fluid overheats, it can lead to premature wear and potential failure of transmission components. The sensor sends the temperature information to the PCM, which uses this data to adjust transmission functions, ensuring proper operation. Since this diagnostic trouble code points to an electrical issue, aspects such as wiring, connections, and the sensor itself need to be checked. A mechanical failure within the transmission is not responsible for this fault, so mechanical inspections can be deprioritized during the troubleshooting process. Understanding this crucial relationship between the sensor and the PCM will help guide further analysis and repairs. Several potential causes can lead to the triggering of DTC P0712. One common cause is a short-to-body ground within the wiring of the ATF temperature sensor circuit, which can disrupt the sensor's functionality. This short circuit can be due to damaged insulation, frayed wires, or poor routing that allows wires to make unintended contact with the vehicle's body or ground. Another possible cause is a faulty ATF temperature sensor itself. If the sensor is internally damaged or worn out, it may no longer provide accurate readings. Additionally, a damaged wiring harness can also trigger this fault, particularly if there are discontinuities in the wires that connect the sensor to the PCM. Finally, loose or corroded connections at either the sensor or the PCM can create variable electrical resistance and contribute to abnormal readings. Identifying the specific cause requires methodical testing of the electrical connections and components involved in the ATF temperature sensing circuit. Symptoms associated with DTC P0712 can vary, but typically include noticeable transmission performance issues, primarily stemming from inaccurate temperature data sent to the PCM. The check engine light will likely illuminate on the dashboard, signaling the presence of the DTC. Drivers may also experience erratic shifting behavior, as the transmission relies on accurate temperature readings to make critical decisions about gear changes. In some cases, an increased transmission fluid temperature can be a direct result, as the PCM may not adjust its operations accordingly. If left unresolved, these symptoms can contribute to long-term transmission damage, making early diagnosis and repair essential. Understanding these symptoms will assist in correlating them with diagnostic findings, ensuring a comprehensive approach to addressing the issue. To begin troubleshooting DTC P0712, the first step is to turn the ignition switch to the on position, which activates the vehicle's electronic systems without starting the engine. This allows you to connect the Honda Diagnostic System, HDS, to read live data from the vehicle. Next, you'll need to check the voltage level for the ATF temperature sensor, labeled as V in the HDS AT data list. Ideally, the voltage should be above 0.07 volts. Any reading that indicates 0.07 volts or less would direct you to proceed to the next troubleshooting step. It's crucial to monitor the readings carefully, as this initial data will determine the next course of action. By systematically recording this information, you'll gain insight into whether the sensor is potentially functioning correctly at this moment or experiencing intermittent issues. The second step involves analyzing the data obtained from the ATF temperature sensor. If the recorded voltage is 0.07 volts or less, you should proceed to the next step of the troubleshooting process, which indicates that there may be a fault within the circuit. Conversely, if the voltage is above 0.07 volts, this could suggest an intermittent error, meaning that the system is functioning correctly at that moment. However, keep in mind that intermittent failures can still be problematic. Further investigation is warranted to check for possible shorts to the body ground, particularly in the wiring of the ATF temperature sensor or the connection to the PCM. By methodically following the troubleshooting protocol, you can isolate the issue more effectively. In the third troubleshooting step, turn the ignition switch to the lock position, effectively powering down the vehicle's electrical systems and ensuring safety before making electrical connections. Next, disconnect the shift solenoid wire harness connector to isolate the circuit affecting the ATF temperature sensor. This step is crucial for isolating components and preventing interference during the following checks. By ensuring a clear path for diagnostics, you're setting up for more accurate readings when the ignition is once again in the on position. Taking care during disconnection and ensuring no other wires are damaged will aid in the accuracy of future checks as you investigate the potential short in the ATF temperature sensor circuit. Now that you have disconnected the shift solenoid connector, the next step is turning the ignition switch back to the on position. This enables the vehicle's diagnostic systems and prepares the HDS to check the ATF temperature sensor once more. You'll want to monitor the same voltage readings for the ATF temperature sensor as done in the earlier steps. If the voltage now reads 0.07 volts or less, it suggests that there is an ongoing issue with the sensor circuit, which may necessitate further investigating the wiring and components. Conversely, if the reading exceeds this threshold, one may need to replace the ATF temperature sensor entirely, as it may no longer be functioning correctly. It's essential to maintain diligent records of these measurements, as they outline the path to further diagnostics. In this step, you will analyze the voltage reading taken from the ATF temperature sensor once again. If the voltage is found to be 0.07 volts or less, it indicates that some faults may still exist within the wire harness or the connection to the PCM. This is a critical point in the troubleshooting process, as it can guide further actions. If the reading is above this threshold, consider replacing the ATF temperature sensor, as it may be unable to provide the correct data to the PCM. Following the replacement, ensure to move on to further steps to clear any diagnostic trouble codes and validate the sensor's functionality. Accurate diagnostics in this step can save time and effort in later repairs, ensuring that the right component is addressed. At this point in the troubleshooting process, turn the ignition switch back to the lock position. This is crucial, as electrical systems will need to be reset for a proper connection during the next step. Next, use the HDS to jump the SCS service check switch line. This action allows the system to enter a diagnostic mode, which can streamline the process of checking other components in the transmission. Following that, you need to disconnect the PCM connector labeled B. which is a 44-pin connector crucial for the communication between the PCM and other components, including the ATF temperature sensor. Ensuring that you follow these steps carefully will minimize the risk of further electrical faults and optimize your diagnostic efforts moving forward. Now it's time to check for continuity between the terminals in the harness. More specifically, you will be checking between terminal number 6 of the shift solenoid wire harness connector and body ground. Use a multimeter, a commonly used diagnostic tool, to confirm that there is continuity, which indicates an unbroken electrical path is present in that circuit. This is essential for understanding if there are shorts to ground that could be causing the faults you are investigating. Such shorts typically originate from damaged or exposed wiring that makes unintended contact with the vehicle's frame. If continuity is present, proceed to repair any shorts found in the wiring between the PCM and the shift solenoid connector. Performing this step ensures that wiring integrity is restored and removes any potential sources of issues before proceeding to the next phase of diagnostics. In this step, the results of your continuity checks will dictate the next steps in your repair process. If continuity is confirmed between the mentioned terminals, you will proceed to repair any wiring issues, ensuring an adequate connection is restored between the PCM and the shift solenoid wire harness connector. Addressing these electrical faults is pivotal, and your repairs should ensure that there are no further shorts to body ground within that circuit. Once repairs have been made, reassemble all connectors to prepare for final tests. If continuity is absent, further inspection of other connecting points may be necessary. Ensuring that these connections are sound will ultimately aid in both clearing the DTC and restoring the transmission functionality. In the final verification step, reconnect all previously disconnected connectors to ensure the circuit is fully closed and operational. Once you have reconnected these connections, turn the ignition switch to the on position once again, effectively powering on the vehicle systems, including the transmission modulator. Using the HDS, clear any existing diagnostic trouble codes, including DTC P0712. This step effectively tells the PCM to forget past faults if they have been resolved through your troubleshooting. Following this clearing of codes, you'll want to start the engine with the shift lever in the P park position and allow it to idle for at least 20 seconds. This will permit the PCM to execute any necessary checks and learn parameters, ensuring that everything is functioning correctly before concluding that the repair is successful. Preventive maintenance plays a significant role in minimizing occurrences of DTC P0712. Regular inspections of the wiring associated with the ATF temperature sensor circuit can help identify potential issues before they escalate. This includes checking for signs of wear, damage, or chafing where the wiring may come into contact with other components or the vehicle's frame. Additionally, maintaining appropriate transmission fluid levels is crucial, as low or deteriorated fluid can negatively affect sensor readings and transmission performance. Moreover, consistently monitoring the vehicle's transmission performance helps to catch anomalies early, allowing for timely intervention before they result in severe failures. Incorporating these practices into routine maintenance will enhance the longevity and reliability of the Honda Civics transmission system. In summary, understanding DTC P0712, the short in ATF temperature sensor circuit, is essential for resolving issues within the Honda Civic models from 2006 to 2011. The systematic troubleshooting process outlined allows for targeted repairs, focusing on possible causes and their respective solutions. By addressing both mechanical and electrical components involved, you can ensure optimal performance and avoid potential transmission damage. Furthermore, prioritizing preventive maintenance and regular checks not only mitigates unforeseen future issues, but also contributes to the overall longevity of the vehicle. Equipped with this knowledge and these practices, you'll be better prepared to maintain your vehicle for years to come. Please like and subscribe to the channel. See you next time.